It'll notify you that I'm recording. So it says use the given zero to find the remaining zeros of the polynomial function. So this time they're saying the given zero is this binomial, this complex number. So we're gonna write, remember to leave spaces, right? Because you're gonna have a couple things happening. So I like to leave a space. So I have my 2. So 3, 2, 1, and none. And then I have my -5, and I'm gonna leave a space. And I have 6, and I'm gonna leave a space. And I have a -2. So I'm using a 1 plus I over here. So this is the given zero, so use exactly that. So we really will have to think about distributing and foiling here in just a little bit. So I'm gonna do all that math over here maybe. So 1 plus I, I'm taking that times 2. So I'm going to put the 2 out in front of it. So we're taking 2 times 1 is 2, and 2 times I is a positive 2I. So that one wasn't too hard. It's still in real and imaginary form. So I'm going to write 2 plus 2I right here. Remember, you need to make sure you align those real numbers because those are the only things that are really getting combined. Those are the only like terms in that column. So -5 plus 2 is a -3, and then bring down plus 2I. Now, this is a binomial and this is a binomial, so we're going to have to do some foiling. We're going to be taking 1 plus I times -3 plus 2I. So 1 times a -3 is a -3. 1 times 2I is a positive 2I. I times -3 is a -3I. And I times 2I is a positive 2I squared. So we have two things happening. We need to combine these like terms. And we have an I squared. So sometimes what I do just to eliminate rewriting it is I will write underneath. This is like saying 2 times -1, right? So what does that number really become? 2 times -1 is what? A -2. So if you want, I just replaced it because now I can see that I have 2 other like terms whenever I combine like terms. You can do that as a second step and rewrite it again if you want. But if you want to do it like that, save yourself some writing, you can. So -3 minus 2 is a -5, and 2 minus 3 is a -1I. So we have -5 minus I. All right. So 6 minus 5 is 1 minus I. So now we get to take 1 plus I and 1 minus I and multiply them. 1 plus I and 1 minus I. And what's going to happen every time in this last step is they should be the same terms with opposite signs because that's how it's going to get rid of an I term. So let's go through that to show you. 1 times 1 is 1. 1 times -I is a -1I. I times 1 is a positive I, and I times a -I is a -I squared. So that one looks really kind of funky probably. Remember, we have a couple things happening. I will go ahead and rewrite this one probably. But 1, and then if you think right here, if I take -I plus I, that zeroes out. So I don't have just an I term. But I do have a minus sign, and then I squared is a -1. So this would be like adding, this would be like saying 1 plus 1, which is 2. So we're going to go put 2 up here, and that zeroes out. And that will happen every time, just like above. If they tell you that that is a given zero, then this will zero out. If it doesn't, you have done something wrong in one of these steps, right? Like if this was our first step here, the first column, second column, third column, that's our space that we were working all that out. So it'll work out just like that. So once you are given a 0, since I do have space this time, we were given, this was our given 0. So just like when we use the opposite sign of negative I before, we're going to use the opposite sign of this binomial and multiply times a 1 minus I. So this one is not given. You're just going to take the opposite sign and go through that step. So bring down your 2, and then I'll do that math over here. Okay, so we're taking 2 times 1 minus I. So 2 times 1 is 2, and 2 times negative I is a negative 2I. So we have 2 minus 2I. So notice right here, these were like terms. They are opposite signs. So we have negative 3 and 2 make a negative 1. But 2I minus 2I zeroes out. So I just have negative 1. So we're going to be taking negative 1 times 1 minus I. So negative 1 times 1 is a negative 1. Negative 1 times negative I is a positive 1I. So see that you have a negative 1 and a positive I. See how negative 1 minus 1 zeroes out? See how negative I plus I also zeroes out. So that should always happen. That should always zero out. So remember, this was now really the remainder column. This is the constant, and this is the x. So what we have, when you are doing these, you're always just going to be working with an x. So you have 2x minus 1 to go find that final 0. So we are going to add 1 over. So we have 2x equals a positive 1, and then we divide by 2, so x equals 1/2. So the remaining zeros, remember what we've learned so far. We knew that there were going to be 3 zeros, right? Because of the exponent. One of those zeros was this ugly complex number that they gave us. That was given. That was this one right here. But we found the other 2 remaining ones. So when you answer this, you're just going to answer 1 minus I, comma 1/2. Because those were the 2 remaining ones that we didn't know for sure. We had to go find them after we worked with the given 0.